Black holes have the power to destroy everything, but can they also be eliminated? What happens if we test the laws of physics to the point where we might even destroy the universe? Let's make a miniature black hole that has roughly our moon's mass and try to break it apart. Big explosions cause damage. So let's detonate the world's nuclear arsenal around our black hole to get the party started. Boom. Black holes consume all energy and stuff that enters their event horizon. Additionally, because E equal mc2, a black hole's mass is increased by all incoming energy. As we irradiate our tiny black hole, it simply grows larger and more massive because a black hole's mass is proportional to its size. Antimatter and matter completely destroy one another. What will happen if we bombard it with an antimatter beam the size of a moon? Sadly, whether a thing is constituted of matter or antimatter, when it enters a black hole, the black hole completely erases its prior identity. Black holes simply consider gravity, which only depends on an object's entire mass and energy. Tossing an anti-moon has the same impact as tossing a moon, since a particle's mass is the same as that of its corresponding antiparticle. The size of the black hole only increases. It's quite intriguing how black holes have this deleting ability. It implies that black holes are comparable to basic particles in certain ways, despite their size and strength. The mass, spin, and charge of an elementary particle, like an electron, are the only three values that may adequately describe the thing. Amazingly, black holes operate in the same way. They can rotate, have mass, and transport an electric charge. No matter where it originated, a collapsed star, an anti-star, or even a banana, a black hole will always be fully characterized by those three numbers and nothing else. Could an anti-black hole be used to annihilate a black hole if it is essentially a strange particle? Black hole anti, how thrilling. The mass and charge of a particle are identical to those of its equivalent antiparticle. An anti-black hole should have the same mass and the opposite electric charge as a black hole because they both have mass and electric charge. What if we bring them together? Sadly, the energy will simply accumulate and disappear. The result of the collision will therefore be a new black hole that is twice as huge but has no charge. We must expand our thinking and push the boundaries of physics. It is correct that a black hole can carry spin and charge. Destroy the event horizon. There are restrictions, though, even for these bizarre objects. The event horizon will dissolve if the black hole's spin or charge increase to an abnormally high level. Singularities are endlessly compacted masses with such intense gravity that nothing can escape from their surrounds, not even light, and are what are thought of as black holes. Because of this, a black hole seems to be a black sphere of nothingness. The boundary of this ultimate prison is the event horizon. If you cross it, there is no turning back. A black hole, however, behaves something like a spinning washing machine when it is rotating. The rotation appears to want to push things away from the black hole and repel them, but this is prevented by the gravity of the black hole. However, if the rotation speeds up too far, this effect will prevail and the event horizon will vanish, freeing neighboring objects from their eternal imprisonment. The electric charge experiences the same thing. If you make it too big, our solid jail will collapse. Even if we were to eliminate the event horizon, the singularity would remain, and things would continue to slide toward it naturally. You would still perish horrifically and soon if you were to strike it. However, the area around the singularity won't be an impenetrable prison any longer. You could approach as closely as you like before returning. The black hole should be declared destroyed as a result. Can we pull it off? Overfeeding the black hole only needs to be overcharged or overspun. Throwing items with low mass and high charge or angular momentum would enable us to achieve this by causing the charge or spin to increase more quickly than the mass. The black hole must be overfed until it approaches the breaking point. However, scientists disagree vehemently as to whether you can actually achieve this. Consider an electric black hole. The more of the same charges you squeeze together, the more they push back because equal charges resist one another. So, Suppose we have a negatively charged black hole that we want to overfeed with particles like electrons, which have a charge much greater than their mass. Electrostatic repulsion will be experienced by the electrons. Additionally, when we send more electrons into the black hole, the negative charge grows and the repulsion becomes stronger. The electrostatic repulsion, however, will become so intense once we hit the maximum limit that it will prevent any additional electrons from entering. The black hole will then rebel against being overfed. The spin operates similarly. The black hole will stop absorbing spin once it reaches its maximum capacity. However, other researchers have found what appears to be a gap. It appears as though we could really overfeed the black hole if we add the correct quantity of matter in the appropriate manner just before it reaches its limit. Even though most scientists are dubious, let's give it a shot nonetheless. Breaking physics, but there's a problem. The singularity is concealed by a black hole's event horizon. In other words, if the event horizon is destroyed, we would be left with a naked singularity, one that is not covered by an event horizon. This is a challenge since it might spell the end of physics as we know it. Black holes have a deep, dirty secret. Contrary to popular assumption, a black hole's singularity is not actually at its center. No, whatever crosses the horizon will have it in the future. Black holes alter the universe so profoundly that space and time are reversed near the event horizon. After crossing it, falling toward the center signifies moving forward. You are unable to flee since it would be as difficult to halt time and go back in time as to stop your descent. In other words, the singularity is not in front of you but rather is in your future. The singularity won't be visible to you until you reach it, just as you cannot predict your own future. However, hitting something that is in your future is equally impossible. All you can do is sort of experience it, just as you will when your next birthday occurs. You will therefore experience the singularity when it occurs to you. Future singularities don't pose a threat to us because we can't observe or interact with them. However, a naked singularity would be visible to all of us in front of us. What might we observe? Well, that's the whole point. You can't know. Gravity is the bending of spacetime, and a singularity is an area of infinite gravity. The bending at a singularity is so extreme that the fabric of spacetime is actually torn. Time and space no longer exist. As predicting entails making a prognosis regarding the where and when of an event. This implies that you cannot foretell anything. But where and when are now meaningless. We therefore have a variable situation with limitless gravity and so infinite energy. This implies that anything, including a solar system or a pile of bananas, could appear out of nothing. The laws of causation, predictability, and standard physics would not hold. Due to our ability to demonstrate that, under extremely general circumstances, gravitational collapse results in the development of singularities, we believe that singularities should exist in nature. But according to experts, nature prevents the production of naked singularities. To stop their madness from spreading to the rest of the universe, something forces the construction of an event horizon around them. The laws of physics might not make sense at all without event boundaries. Thus, while being depicted as the universe's worst villains, black holes may actually be the heroes that protect mankind from the lunacy of singularities. Therefore, if we do break the horizon, we might also destroy the underlying laws of the universe. I tell you what, don't let's do that. The secure choice as far as we are aware, there is only one safe way to obliterate a black hole. Wait. Hawking radiation is the phenomena that all black holes emit. They eventually evaporate due to this process, leaving behind neither a horizon nor a naked singularity. A black hole's mass determines how long it takes to totally vanish. It will be around 1044 years for our miniature black hole, which is the size of a dust particle. This is 10 billion trillion times the current age of the universe. So, can a black hole be eliminated? Less. All we can do is wait.